Hi, we're the Ocean Going Robots ECE Capstone team. The goal of our project is to develop a system to measure swell amplitude, direction, and period of waves from the Slocum glider as it floats on the surface of the ocean while consuming a minimal amount of power.
So our goals from the previous weeks were to finish the first draft of the project wiki, complete the system verification assignment, begin assembling and bringing up the PCB boards, and prepare for system verification.
Yeah, so we were able to finish the first draft of our project wiki and submitted it to our project partner for review. They liked it overall. They had some suggestions to improve its clarity, and we implemented those. We might be able to take a peek at it here. Yeah, it kind of looks like a wiki. Got all sorts of different subsections for various aspects of our project. We're pretty pleased with it.
So we also checked off the first two project requirements for the first system verification. The ones we chose to do were the PCB dimension requirements as well as the SD card connector clearance requirements. Both of those, the PCB barely came in underneath our threshold, which works fine, and the SD card connector fit perfectly. We also met all of our project's universal constraints, and we're beginning to working on the next ones now.
So end of last term and in the past week and a half, we have been working on bringing up our main system PCB. The system PCB contains the microcontroller, the accelerometer, as well as the interface to the SD card and our buck regulator and some other supporting circuitry. So we've assembled the microcontroller and we have tested that it can talk to the SD card, and we've also assembled a lot of the supporting circuitry around that. And we've been able to, load test firmware on there and prove that the microcontroller is working fine. So that's been good progress. We also assembled the buck regulator on a separate PCB with no other components on there. Reason being that if the buck regulator had a design issue, it could potentially damage the low voltage components. And so we wanted to test that separately before we put it on our main system PCB and connected it to everything that we already have working. So the bring up progress has been going smoothly, and we are, I would say, around 70-ish% complete with the build of the main system board.
It turns out it was a very good idea to build the buck regulator on a separate PCB by itself, because when we built that up, we found that the output voltage had a huge amount of voltage ripple that was like larger than the actual voltage level that it was supposed to be. And it turned out that the issue there was that the output capacitor we used had too high of an ESR. It had about 9 ohms. And it was because that was an aluminum electrolytic cap. And by swapping that out with a ceramic capacitor, we were able to get the ESR down to more like 0.3 ohms. And we tested that the other day and it seemed to work well. It had a lot less voltage ripple.
So our goals for the next week are to continue building up the board and testing those individual blocks as they're assembled. We're also going to begin compiling our firmware and creating a final firmware that we can upload to the board and fine tune for the final project submission. Additionally, we're going to continue working on our project documentation, including the wiki and the draft for our poster. So stay tuned for exciting new things to come.
Nice.